things two things covered successfully. So we have discussed DFS and BFS. After that, we cover the after after we cover the portion of portion DFS and the DFS and BFS. Too much and the cycle portion already completed. So we move forward for the next term. Next term, next term is shortest path. Shortest path. So shortest path. First question come in our mind is Dakshatra, Belmont, Bird Warsal, shortest path. All these are the algorithm. So Dakshatra to find the shortest path of the source to all. So a given weighted or undirected graph. Weighted undirected graph. Weighted and it is for the weighted undirected graph. Weighted and undirected. Okay. Weighted and undirected graph. And each represent a source and vertex. Find the shortest path within source to vertex to all other vertices of the graph. So source to all other vertices. Source to all other. Okay. Source to all other vertices. So let's say directed undirected source to all other vertices. So graph by vertex number from the graph vertices known as from the 0 to V. The vertices are given as. The given graph does not have any negative edges or and terms and conditions also apply. What that is that there must be no negative edge. Okay, connected better and so 0 to V, no negative edges. So this is known for the Nashatra algorithm. So sources given as 0, vertices are 5, and the edges are all the connected 0, 1, 4, 0, 1, 4, all the vertices. So it's just like 0, 1 uh, and debit is in a slice to 0. From there, we iteratively pick the unprocessed node with the minimum distance from the source. There is there is where a mean heap or set to priority used for the efficiency. For the each peak node you update the distance to its neighbor. The formula is equal to distance of u plus distance of u v, but only if the new path offers the shortest distance to the current node. So, uh, so let's write the steps. So steps are as follow. So step one. Step one. So step one. Set a distance. Distance of source is equal to 0. Okay, and all distance at infinity, and all other all other as infinity. Okay. Okay. After that, first step one. Step two. Push the source node into the mean heap as a pair of distance and node. So choose the node to mean heap a pair. So pair consists of distance and node. Okay. So for example, if we push, it look like 0 comma source. So okay, distance and node. So distance as infinity, push the node into the pair, and the top of the element from the mean heap. Pop the top of element neighbor, and the calculate formula is equal to distance of v, and distance of v is equal to distance of u plus the weight of u UV. Okay. If the distance new is if the distance new is shorter one, if the distance new is shorter one, new distance will be new distance will shorter shorter one. This means that we have to update. We have to update. Okay. If new distance will be shorter, so we have to update. Okay. So repeat step 3. Repeat step 3 until the mean height is empty. Repeat this step. The mean height empty. Return the distance array. So which hold the shortest path from the source shown. So it return and finally it return return the vector that hold uh, return the vector और vector क्या करता है vector hold करता है shortest distance to all nodes. Okay, from source source. Okay, return the vector shortest to the all the source. So Dijkstra algorithm is this. Dijkstra weighted vector source solver 0 from start, no negative. Dijkstra step 1 and distance 0, all other infinity. Push the node into mean heap as a pair of distance and nodes. Example 0 comma source. And if the distance of v plus distance plus u plus weight of this distance is shorter than previous one, we have to update. Repeat this until the priority queue become empty. At the end of this our calculation, we have to return the vector. The vector consists of sorted distance to all nodes from the sources. So let's write let's write code here. Let's write code in this section. So Chitra algo. So the code start with the vector of inconsisting of the etc. dj. Okay, in which in which the vector in which the size of vector and the vector of dependency is vector of int direct edges edges and the integer of source. These three things are given. So create a density matrix. No need to create. After that, we have to create a priority queue. Create a priority queue to store the vertices that are processed. The process of the source is denoted as 0. Looping till the priority will become empty and distance are not finalized. So the first vector in the pair is the minimum distance and the vector extract it from the priority queue. Int u is equal to pq dot top, the first element dot top. Get all the distance of u. Auto x is equal to adjacency of u. Int v is equal to, so v percent where is connected, what is the weight? If weight of v is greater than weight of u plus this, so we have to update the vector and push back to. Weight of v is greater than u plus this, weight of u plus this. So we have to update the So that's the time complexity is equal to order of E log V. So based on the path, shortest curve area, path of smallest. Let's see. Let's see this approach. Path of smallest. Let's see. See this. Switch to the well, let's say the Kshetra algorithm is covered here. Priority queue, all these things. So the problem based on shortest path. The problem based on shortest path will be there. So you are given a weighted directed acyclic graph and the source vertices graph. Find the shortest path for the given source to all the nodes. For the general weighted graph, we can calculate the uh, single source balloon for this. Like Chitra will be this. So how will we define? This will define only the part. For next step, like Chitra will discover here. So the problem based on shortest path. Mean cost path. The minimum cost path left, right, bottom, up and down allowed. So you are given a 2D grid of and cross and where each cell is represented the cost of traverse through the cell and the task is to find the minimum cost to move from top left to bottom right from the given cell in 4 direction. So the idea is to use the Nakshatra algorithm to find the minimum cost path through the grid. This approach treats the grid as a graph where each cell is a node and the algorithm dynamically explores the most cost effective path from the bottom right cell by the always expanding to lowest cost. So use the mean heap, always process the lowest and cost path. So how this will look like this. So let's see canvas portion. Minimum cost path. Okay. Let's see. So we have created a grid priority key of vector, vector of int, vector, vector, and vector of this. So 2D and 2D matrix, 2D stored minimum cost. So vector vector cost of int, cost of 0 is equal to grid of 0. The direction to move in 4 direction, vector vector of int dr is equal to this and this. Push the grid and the coordinates. pk dot push while the pk empty, pk dot element is equal to pk dot top, and int c cost is defined as this. I element is pk dot top and j is equal to pk dot top 2. So explore all the direction. X is equal to I plus of 0, j is equal to this. If it is safe or not, its bool condition is valid I, j, and n greater than n, less than n. These are the valid cell and cost of I. If cost of I plus grade of I is less than cost of x plus x comma y. So we update the cost by cost of x comma y, cost x plus y, put the value into this and new, and we have to return the. So simply through the etc we find the cost of the. So how can we write? Let's see. The question number third. So main cost path, how will we define? So let's make mean cost path. So title will be mean cost path using etc. Okay. So how will we make? So we have to return mean cost. So mean cost. Okay. In mean cost we have provided a 2D vector. So vector of integer type having name as a grid. So 2D vector as a name of grid. So firstly n cross n grid, int n is equal to grid dot size. Okay. Grid dot size. Create a mean heap and then a priority underscore key vector of integer comma vector inside this also vector of integer type comma, and after that greater which consists of vector. So greater vector of int 1 2 and is known as pq. Okay. So first of all create this and also create uh, cost vector same as a grid. So vector in which we show the answer, not modifying. Vector of integer type is name as cost size of n vector of int size of n, firstly initialize as the int max value int underscore and max value. Okay. This thing, if these three things are created. So cost we have to fill cost of 0 value present as a grid of 0 comma 1 0 comma 0. So grid 0 comma 0. After that we have to explore all the four directions. So we have to create a vector vector of distance. So integer type. So dir. Okay. Dir consists of the direction. So direction will be four directions. So 1 comma 0. After that 1 comma 0 minus 1 comma 0 0 comma minus 1 0 comma minus 1 or 0 comma minus 1 or 0 comma 1. So all four direction is covered here. So explore. I've tried to exploring all the distances. So first of all, you dot push. What is push? Figure out push the grid value, grid of 0 comma 0 value and the distance and the distance coordinate is 0 comma 0. These are the coordinates and iterate the pq loop till it become empty. Okay, so first of all we extract the first value. So it will be in vector form. So vector of int top is equal to pk dot front. Okay, pk dot front on the vector form and pk dot pop. So int will become the cost. So top of 0 return the cost items written as a top of 1 and int j will be top of 2. Okay, all things are extracted from the vector of the top, and now we check. Now we have to check, and I check for all the four directions. So for auto or auto it over dir. So we check int new I, the new direction is equal to I plus it of 0 and int new y is equal to j plus it of 1. So new direction will be given as this, and check is valid or not. If the cell is valid or not, you have to check if valid or not. If is safe, is not, is uh, as is safe. What we pass x comma y comma size, x comma y comma the size of the, if it is safe, and cost of I, cost of I comma j, cost of I j is less than cost of x comma y. If less than this, we have to update the x comma y a new. So new one. So cost of x comma y become I j, next will become same as this cost of I plus this. Okay, and simply pq dot push, simply pq dot push cost of uh, simply push cost of y comma and the new direction. So new direction x comma y. Okay, after returning that, the cost table become full, and finally we have to return cost of n minus 1 and minus 1. So final answer will be stored in this form. How we see the minimum cost path using etc. So, okay, simply creating priority queue, and the cost of 0 is equal to grid of 0 assigning four direction. Simply push the first element and run the operation till pick would become empty or not. So stop and this will be done. So this question will be clearly dusted. Oh, okay. This question is clearly done dusted. So print smallest print the negative cycle, okay, shortest path in binary image. Shortest path in binary image. This minimum state to reach the target. So these two questions, shortest path in binary image. So you are given m cross n matrices where each element can be 0, 1. We need to find the shortest path between source cell to destination cell. The path can be created out this cell of the value 1. So you can move in adjacent in one or four direction up, down, left, right if the adjacent cell are filled with the ones. Like example, 1 1 1 0 0 0 1. So source will be 0, 1 and the destination is 2, 1 0 1 2 0 1 2. This will be destination. So 1 2 1 2 3 0 so 1 so 1 1 1 2 so 1 is same. The cost becomes this. Simply same as previous question, but this time we have to check bool safe condition. Next cell not is equal to 0. So is safe condition matrix visited or not into x or comma y. If x is greater than 0, x is less than this, y is greater than y, and if matrix is equal to 1 and not visited, then it is true. So same as previous one, same as int x if I is equal to, let's see, let's see, okay. So so all these things happen and given as vector visited boolean path, shortest path, shortest path boolean. So start with the answer. All these things are already given. So if my size is equal to 0 and first and second, so it is equal to 0. So row is equal to this, column is equal to this. Create a visited matrix and define this as a equal to shortest path, max, source of first, source of second, destination of first, destination of second, comma 0. If destination is equal to return -1. So same shortest path. If I is equal to destination, j is destination, minimum distance is equal to mean of distance plus mean destination. Okay. So simply make it visited and check the new cell is safe or not. Safe. If safe, then shortest path for the I plus 1, distance plus 1. Go right. So 4 into n cross n. So using expected approach is DFS. So simply moving here and there become too complicated. So use DFS. Okay, points. So minimum step to reach the target by knight by 1. You are given a square chessboard of n cross and the position of the knight and the position of the target are given. We need to find out the minimum step a knight will take to reach the target position. So either minimum step 1, 2 and 3 step. Minimum step taken by the knight to reach the position. Minimum step needed to reach right. So the position is equal to 1 comma and they needed to reach the target as 5 minutes. So how many steps it needed? So So this problem can solve the shortest path in the unweighted graph connected like. Therefore, the PFS is appropriate. So start with the night initial position and mark as weighted. Initialize the queue of DFS where each entry stored the night current position and the distance from the starting position. Explore all 8 possible moves a knight can make. Granite check if a new position is there in a whiteboard or not. Okay, so simply checking the correct abstract cell in x comma cell this. So all 8 direction move 2 minus 2 comma 1, all 8 direction is mentioned. All 8 direction must be this one. This will be 0 1 2 minus 1 minus 2, same as up one. So it move one step, two step up and one step is left. This position will be 2 comma 1 minus 2 comma 1 minus 2 comma 1 minus 2 comma this. So all the 4 direction will mention. Create a cell, create a queue, and here we put night position 0, night position, and choose a starting position of night with the distance, and distance will be 0. So cell t x comma y, the vector will be visited n plus 1 will be visited. Okay, if visited of start waiting, if visited true. So table q dot front. So t dot x is equal to target position and t dot y is equal to t dot distance. If we reach the distance, we have to return the distance. If not, we have to check is safe, not weighted, then you have to mark the weighted and put the cell and distance. Okay, if not match, then minus 1. Simple one. Uh, so number of way to reach the destination shortest time. And the last question for this topic is the number of way to reach the destination in shortest time. You are given an n cross n 2D integer array of edge where edge of I is equal to n. Mean that there is a edge between intersection ui and vi to make a minimum time to reach. You want to know how many ways you can travel for the intersection of 0 to minus 1. The shortest amount of time the task is to return the number of way arrive at destination. Like n is given and m is given. So n is given. So time and time. So you want to how many ways to reach the intersection. So 0 6 0 4 6 time. The goal is to travel the intersection of this time. So we do not understand this question, but see the approach. Question. Int count the path vector of their int of graph edge graph dot push is a point and to create a long distance and the path priority of long int vector of long int pq push 0 comma 0 distance 0 to path 0 while pk is not empty t is equal to this. So what is a t dot second? If never dot first, never dot second. If never dot is true, greater than this and this, so update the value and push inside this. Okay. Okay. Till now we have completed the shortest path thing, in graph. So shortest pathing is covered. So we see that. mm, so shortest path in Dijkstra algorithm, shortest path will be covered. There is no need of Bellman food. Shortest path is completed. So mm, shortest path is covered. The initial portion is covered. So covered. So in next time we have topo sort. Topo sort. So graph one topic is sufficient for the kernel. Next time we have to study about DP. Next section we have to study DP. So